Hello students, welcome to our online lecture for BUM2123 Plat Calculus. This lecture is on topic 2.3.1, the unit tangent, unit normal and binormal vectors. So in our module, this topic is on page 142. So as you can see here, this topic deals with a formula. So here you have the unit tangent vector formula. Here is the unit normal vector formula and as well as the binormal vectors. Okay, let's see the example 2.3.1.3. In this example, we have a vector of r equals to cos ti plus sin tj. And the question asks you to find the unit tangent vector and unit normal vector at time t equals to pi over 3. So let's solve the problem here. So I have r equals to cos ti plus sin tj. So I can write this vector in bracket as this one. So the unit tangent vector just now, the formula for the unit tangent vector is the derivative of r, which is the r prime, divided by the magnitude of the r prime, in which the derivative of cos will be negative sin t and derivative for sin is cos t. Therefore, the magnitude of negative sin t cos t will be negative sin t squared plus cos t squared, and everything is to the power of 1 over 2. So we have here sin squared t plus cos squared t is equals to 1. So everything in the denominator is equals to 1. Thus, you have your answer for the unit tangent vector as negative sin t and cos t. If you still remember, the question asks you to find the unit tangent at time t equals to pi over 3. So we just substitute the value of t by pi over 3. So if you use your calculator, you will get this answer. Next, we will solve for the unit normal vector, which is n. Again, the formula for n is the derivative of your unit tangent vector just now divided by the magnitude of the derivative of the unit tangent vector. So your unit tangent vector is negative sin t and cos t. So differentiate negative sin t, you will have negative cos t, and differentiate cos t will have negative sin t. So again, the magnitude of this one will be and this is equals to 1 again. So the answer is negative cos t and negative sin t. And the question also asks you to find the unit normal vector at pi over 3, at t equals to pi over 3. So substitute back the value of t by pi over 3. You will have the answer of negative 1 over 2 and negative square root 3 over 2. So if you look here, you will know that you get the correct answer for your unit tangent vector and unit normal vector if the dot product of the two vectors equals to 0. That means that t is perpendicular to n. The unit tangent vector is perpendicular to the unit normal vector. Okay, So we have our unit normal vector already. Let's see what the unit tangent vector and unit normal vector actually means. Okay, let us look into this graph. Okay, just now we have our R as cos t and sin t. So the parametric curve for this vector function is a circle, if you still remember from our previous topic. So you have a circle like this red circle here with a counterclockwise direction. So the unit tangent vector of time pi over 3 is equals to negative square 3 over 2, 1 over 2. Okay, the vector I here, the direction for vector I is along the x-axis, either to the left or to the right. And the direction for vector j is along y-axis, either upward or downward. So the negative value imply left side, and the negative value for j imply downward. So this is negative and this is also negative. So if you see here, the unit tangent vector shows the value of negative square root 3 over 2 and 1 over 2, meaning to say we have a negative direction for the x-axis, okay, and the positive direction for the y-axis. Thus, this is our tangent vector, okay, as this is negative square root 3 over 2i, and this is our 1 over 2j. So our tangent vector is here pi over 3. The same direction imply for the unit normal vector, the n. So as you can see, our unit normal vector, we have negative 1 over 2 and negative square root 3 over 2, which means we have to the left direction and then downward. So starting from the exactly the same point here, so we have negative 1 over 2 and then downward square root 3, negative square root 3 over 2. Thus we have this as our normal vector. Okay, now let's take a look into example 2.3.1.4, in which the question asks you to find the unit normal and binormal vectors for the circular helix r equals to cos t I plus sin tj plus tk. So we have a vector of r equals to cos t, sin t and t. Okay, so to find the unit normal vectors, the unit normal vectors formula is t prime over magnitude t prime. Therefore, in order to find the unit normal vector, we have to find the unit tangent vector first, which is unit tangent vector is equals to r prime over magnitude r prime. So we differentiate the r, we will have negative sine t cos t and 1. So the magnitude of negative sine t squared cos t squared plus 1 squared square root will be negative sine t cos t 1 over, this is 1 and plus another 1, so we have square root 2. So we have to differentiate our t to find t prime, and this 1 over square root 2 is only magnitude, so we bring it forward and differentiate the negative sine t cos t and 1. We will have negative cos t, negative sine t, and 0. So our normal vector should be 1 over square root 2 negative cos t negative sine t 0 over 1 over square root 2 cos t squared plus negative 1 over square root 2 sine t squared square root. In which this one we will have 1 over square root 2 negative cos t negative sine t 0 divided by, so again the cos squared plus sine squared is equals to 1, but then we have this scalar, okay, so we will have 1 over square root 2 here, so we can cancel out this 1 over square root 2, so we only have negative cos t negative sine t and 0 as our unit normal vector. So the question asks you further to find the binormal vector, which is b. Okay, so we have two different formulas to find binormal vector. Since we already have our t and our n, so we'll use this formula, which is the cross product of tangent vector and the normal vector to find binormal vector. So the cross product of ijk, tangent just now is negative 1 over square root 2 negative sine t cos t and 1, and then n is negative cos t negative sine t and 0. Okay, so the cross product for unit tangent vector and unit normal vector will yield the binormal vector. So we solve for this cross product, so we will have a 0 minus negative 1 over square root 2 sine t for I, minus another 0 minus negative 1 over square root 2 cos t for j, and then plus 1 over square root 2 sine squared t minus negative 1 over square root 2 cos squared t for k. So we'll have 1 over square root 2 sine ti minus 1 over square root 2 cos tj plus 1 over square root 2 k. we will have 1 over square root 2 sine t minus cos t and 1. So this is the same as our answer here in your module. So let's take a look into our next example. Might be our last example. The example of 2.3.1.5. So I have a r equals to t, 2 cos t and 2 sin t. And the question asks to find the unit tangent vector and unit normal vector at point t equals to pi over 2. So again, we find the unit tangent vector first, which is r prime over magnitude r prime. So we differentiate our r, we'll get 1, negative 2 sin t and 2 cos t. And then we find the magnitude for that. We will have 1 squared plus negative 2 sin t squared plus 2 cos t squared to the power of 1 over 2. So we will have this one is 4 plus another one will be 5, so square root 5. Okay, so this is our unit tangent vector. The question asks to find the unit tangent vector at time pi equals at time t equals to pi over 2. So we have negative 2 sine pi over 2, 2 cos pi over 2 over square root 5. Okay, so this cos pi over 2 is equals to 0, and then this sine pi over 2 is equals to 1. So I have a 1 over square root 5 and negative 2 over square root 5 as my unit tangent vector at time t equals to pi over 2. So we solve for the unit normal vector, which is n equals to t prime over magnitude t prime. So our t just now is this one. Okay, so 1 over square root 5 is only a scalar, so you can bring out the scalar. So we differentiate for the 1, negative 2 sin t and 2 cos t. We'll have 0, negative 2 cos t and negative 2 sin t over squared plus negative 2 cos t squared plus negative 2 over square root 5 sin t squared square root. Okay, so we have a unit normal vector here, and we want to substitute the value of t equals to pi over 2. But before that, we solve for the denominator here, in which everything here will becomes square root 4 over 5, which is, okay, since there's 2 here and 2 here, if I take out the scalar 2, so we'll have 2 over square root 5, 0, negative cos t and negative sin t, and this will be 2 over square root 5 as well. So I can cancel out these two, and what's left is only the 0, negative cos t and negative sin t. So substitute the value of t equals to pi over 2, you will have negative cos pi over 2 and negative sin pi over 2, in which this is equals to 1, this is 0, so we'll have 0, 0, negative 1. Okay, so if you see here is the same as your, I have the answer in your module, which is it becomes negative. Okay, so that's it for the unit tangent vector, unit normal vector, and binormal vector. And please do all these exercises and tutorials in your module. And thank you for taking your time to see this online lecture. See you.